Hello, everyone. We are back in the OpenAPI technology tracks. We had three great talks about interfaces, why they're important, about the async API specification with the co-creator, Fran Mendez, who were explaining the state of async API. We had a great talk about how we can build API specs with engineering teams and how we can collaborate around them. And now we have about this state of OpenAPI, async API, and OAuth track. I'm really glad to host on stage Cliffano, Subagio, about a new tool that sounds really exciting, OpenAPI Generator. And they call it the Babel fish of the API world. Hello, Cliffano, how are you?
Hi, Mehdi. Good, thanks. How are you doing?
Good, and we are doing really great. Your slides are in full screen. The stage is yours for 20 minutes, and we'll love to hear question from the audience at the end.
Thank you. Thanks a lot. Good day, everyone. Today, I'm going to talk about OpenAPI Generator, which is the Babel fish of the API world. And this talk is going to describe a bit more why I think that this library is the Babel fish for the various programming languages that are being used across various technology stacks in the API world. First of all, thanks very much for stopping by and spending the time to watch this presentation. And a little bit about me. My name is Cliffano Subagio. I'm a principal engineer at Shine Solutions in Australia. And I'm also a member of OpenAPI Generator Technical Committee. It's really just a fancy way of saying that I'm a contributor to the project. To start with an agenda, so this talk, I will start with what I think is the problem in the first place with having polyglot systems and the need for a Babel fish. And then I will introduce you to OpenAPI Generator library. And then I will walk you through some of my use case scenarios. And then to close it off, I will wrap up, put some summary on what I have presented, and extend an invitation to also contribute to the project if you find the project to be useful and if you end up using it, for example. So to start with, so the polyglot systems and the Babel fish. So it all started with my journey from back in the year 2000s. So I was working as a Java developer, and I was working mostly with Monolithic J2E applications. And back then, there was a mindset in the community that everything should be 100% pure Java. So you're writing a backend logic, Java. You're connecting to a database, use Java for the database driver. Mobile stuff, Java, right? So everything Java, UI, Java. And if I try to illustrate that in a simple diagram, so a Java monolithic application is just this rectangle with just Java, everything there from top to bottom, from one end to the other end. Really, it's just Java. Fast forward 10 years later, I went to a conference in Melbourne, Australia called YAOConf, so 2012. There were two talks by a gentleman by the name of Fred George. And the first one, he talked about microservices architecture. Bear in mind, this was in 2012. So nowadays, microservices, service-oriented architecture, some people call it like mini services, tiny services. It's really common. But back then, it was one of the earlier days of microservices architecture. So Fred was describing a project that he did, and it had a language agnostic set of services, which was quite refreshing coming from a background where everything had to be written in Java. The second talk that he delivered was on programmer anarchy. And in this second talk, he was describing how his team had the authority to actually decide what programming language to use for any service that they built. So at the end, they ended up using a mix of Ruby, Clojure, C++, and Node.js. And not only that, if for example a service was written in one language and then 3-6 months down the line someone could justify that it's better be written in another language that is more suitable for the purpose of the service, then they actually had the capability and the authority to make that change and introduce another language. So that made me think further, and if I map that to again the diagram, so it was really a set of like polyglot multi-services. This is just an example. Let's imagine that there are two systems, one on the left, one on the right. It has a mix of languages, Java, Ruby, Clojure, Python, and then Node.js, Go, and .NET. And they have to talk to one another within the system and then between those two systems and within the systems. So the question here is like, if they're written in so many languages, how many boilerplate code that you have to do in order to do basic stuff like handling the payload, talking via HTTP, HTTPS, dealing with authentication. So that actually reminded me to, hopefully many of you are familiar with the Hitchhiker Guide to the Galaxy, popular radio show from BBC from late 70s. So in the Hitchhiker Guide to the Galaxy, there is this thing called the Babel fish. So the protagonist in the story was not able to understand an alien who's speaking in an alien language that the person is not familiar with. So the Babel fish works by sticking the fish into your ear, and then suddenly you will be able to instantly understand anything sent to you in any language. So that's a bit what I thought would be needed for a polyglot multi-services system. Stick one Babel fish to Java service, Ruby, Clojure, Python, right? So, and this Babel fish serves as the bit that translates the alien language. Now, I was hunting for a solution. What would become this Babel fish? So back then, that's when I encountered OpenAPI Generator project. So what is OpenAPI Generator project, right? So it is an open source library. Its function is to, it's a code generator. The library itself is written in Java. It uses Mustache templates. It generates API client server stubs and a set of documentations. As of now, it supports more than 40 technology stacks. And the history of OpenAPI Generator, it is actually a community fork of Swagger CodeGen, where majority of the top contributors ended up moving to OpenAPI Generator. And at the moment, the project OpenAPI Generator has more than 10,000 GitHub stars, and 2,000 plus GitHub users have contributed to the project. Now, how does it work? So you always start with an OpenAPI specification. So on the left there, OpenAPI specification, you pass it to OpenAPI Generator library, which uses Swagger parser to parse the specification. You get the information from the specification. I will describe a bit more what the specification might look like. And then the information is then passed to the generator templates. And then OpenAPI Generator contains so many templates for so many technology stacks. And for example, if you want to build API client in Node.js, in Python, in Ruby, so there is a set of templates for each of those technology stacks. So it produces API clients, API servers, and documentations. Now, let's have a look at a simple example to illustrate what OpenAPI Generator can do for you. So there's a service called IPFi. So the host name is api.ipfi.org. This IPFi service is doing simple thing. If you send a request to the service will return your public IP address. So just a simple service with one endpoint. So you send a GET request against the root path / and pass in a query string format JSON. And then IP5 service will respond with 200 OK and a payload in JSON with an IP property, and that contains the value of your public IP address, right? A simple example, just a simple service with one endpoint. Now, how do we use OpenAPI generator against a service like this? So, so we start with an OpenAPI specification. So there are several parts of the specification. So metadata, where you define a number of information about the specification itself, the version, who's the author, what's the licensing information, some description about the specification. And then you can also define the host of the server of the service. And then you define the path. So for the IP5 endpoint, it's just a slash, really. It's just on the root path. And it supports request and get method. And then you define the parameters for this get method. So the example there is that you can pass in format, and you can pass in the value JSON. And it's not a mandatory query string. And then you can define the responses. The responses, in this case, you can define for a response to 100, it will respond with a payload. And for the payload, you can define a schema for the payload. So the last bit there in the specification, you can define a schema, and the schema has an object called an IP, and it has one required parameter, which is called IP as well, and the value is a string. So this specification defines what the service is about. Now, you can then pass that specification to the generator. There are many ways to run this: Java, NPM, Homebrew, Docker if you use containers, and then specify what technology stack that you want to use. In this example, it's Python. And then you have the specify the output location. It's really simple. You have a specification as an input, define the technology stack that you want to use, and then spit out the generated code. What will be generated? A lot. So project structure, metadata, README, documentation, markdown documentations, library dependencies. If you're using generating Node.js code, it has the package.json file with all the necessary libraries. Same thing with Ruby gem file, Python requirements.txt, Maven POM. So it takes care of a lot of those. It also generates some unit tests, some API clients, and API server stubs. So here's some examples of what will be generated. So the example here for Python, Ruby, and Node.js, it produces those files on the list on the screen. And yeah, that's not a small amount of code. And bear in mind, this is just for one endpoint, a simple service for IP5. And if your service has dozens, if not hundreds of endpoints, then the amount of boilerplate code that you get out of the box from OpenAPI generator is actually massively a lot, and it is a massive time saver for you. And just for fun, a Java generated code will look like this. So a lot of files, considering the verbosity of Java. Now, here's an example of how Ruby API client is used. So with the Ruby client, it generates a module called OpenAPI client, which you can require in your Ruby code. And then you create an API instance and then make a call to get the IP. So from the instance, you call get IP method and then pass in the query string format JSON, and then you get the result output model. And the result contains the schema IP model that you define in the specification. And then if there's any error, then you can trap the get IP call with a begin rescue end block. And then you can work with the error. In this case, I just displayed on the screen. And what are the supported technology stacks? So it's a lot. So those are the logos. You might find some technologies that you use. And yeah, there has been new technology stacks being introduced and added along the lifetime of the project. And it's definitely a lot of effort to build this technology stack coverage. Now, let's walk through some of my use case scenarios of using OpenAPI Generator. The very first one that I used OpenAPI Generator for, well, back then it was called Swagger Code Gen, was on an enterprise service bus project where there is an ESB in the middle and then services along the way. So back then it was mostly Java. The services were mostly written in Java. There was one or two which were written in Python. But to simplify the interaction with the ESB, we defined these endpoints in an OpenAPI specification and then generate various API clients, which then get consumed by the services. And then another interesting example would be the project that I was working on had to do with API gateway and its provision using OpenAPI. The talk after following my talk here, Ole Lensmar will actually be presenting about how to use OpenAPI to do with creating API gateway. So that will be a good one to follow through after this. So this API gateway that I was working on had several consumers, internal and external. And the internal one uses Node.js and Python. The external one used Go and Java. So it's really a mix of things. And to have all of them having to write the boilerplate code for interacting with the endpoints will be quite a nightmare. So we ended up, again, generating the clients and then pass them across to these consumer services. One interesting example that we ended up using OpenAPI Generator was for modernizing the provisioning infrastructure of a legacy application. So bringing this a legacy, a really old application with pre-REST API technology, and we ended up using Puppet in Spec, Ansible, some command line using Node.js and Java Spring Boot application to orchestrate the application. And all of these tools interact with the application through SDK Clients, again, generated by OpenAPI Generator. So the use case is not just the classic services architecture, but it's also useful for infrastructure as code. And here's another interesting example. OpenAPI Generator also produces a baseline JMX file for JMeter performance testing. So if you have a ton of endpoints to test, having this baseline JMX file will be a massive time saver as well. You can then tweak the generated JMX file after the baseline is generated. Another example for an open source project, Jenkins, I created a library called Swaggy Jenkins, and it generates various clients, and then that can then be used for notifying smart lights for voice application to control Jenkins. So again, this is another uncommon use case. If I can have 3 tips for maintaining OpenAPI Generator related code, it would be integration testing. Why integration testing is the ultimate thing that you must have in such project is because things just simply change all the time. Throughout my lifetime of maintaining those projects, I use OpenAPI Generator 4. I've gone through OpenAPI specification from version 2 and version 3. The generator itself has evolved from version 2, 3, 4, 5. Python, the programming language, Python 2 to 3, Ruby, many versions along the way. The application changes. Dependency vulnerabilities triggers dependency versions to be updated. And then environment changes as well. You might move from virtual machine to a Lambda function and so on and so forth. So the easiest way to verify all of this that would still work is by having integration testing along the way. Now, to wrap up on this talk on the introduction of OpenAPI Generator, if you remember the Babel fish I showed you at the beginning of the project of this presentation, I was looking for a Babel fish that I can insert to each of the service, and that solution ended up to be this OpenAPI generator project. So by creating API clients and the API servers for all these services in multiple languages, it is really, really useful, and that helps a lot with the fact that these are polyglot systems, and we need this Babel fish. If you're interested and want to have a look at the project, the website is openapi-generator.tech. OpenAPI Generator is multi-technology stacks. It has multi-technology stack support. It gives you boilerplate code for free, and it is a massive, massive time saver. Maybe a quick introduction to what you can contribute. So obviously there are so many things, documentation, bug fixes, introducing new technology stack. My first contribution to the project back then was I optimized the file downloading for the generated Ruby API clients. A problem that I hit back then was that if I use the API clients for downloading large files, gigabytes upon gigabytes, it failed at 2 gigabytes, which is the maximum that Ruby can consume by default. And it turned out it was because the implementation of the Ruby API client was buffering the file being downloaded. And the fix was really to refactor the implementation from buffering to streaming. And that just put a limit on how much memory Ruby will consume. And in my case, for my testing, it just used 100 megabytes instead of trying to occupy 2 gigabytes, and then it then breaks and the whole thing collapses. So it's a really simple thing, quite fun, and yeah, like it's really, if you would like to have a look and contribute as well, your contributions are definitely welcome. That's a website as well on GitHub. And if you would like to help to become a sponsor, we also have a page on opencollective.com. And yeah, thank you very much, everyone. And if anyone has any question, I'll be happy to answer.
We have 3 minutes for questions. The first question is, someone is asking, is it related or tied to the OpenAPI initiative officially or not?
No, it's not tied up officially. So it is definitely a community fork from Swagger CodeGen. Most of the contributors, if not all, used to be part of Swagger CodeGen. And at one point it forked out, and the contributors ended up with a separate set of tools.
Yeah, open source is also for that, right? Ability to fork when the roadmap is not going in the direction it should be. At least a part of the community wants to go, right? Okay, really interesting. Today, so you said about how people can contribute, but today, like, where do you see it going in the next years? Like, what do you want to achieve at the end with OpenAPI Generator?
I think so I discussed this with the core authors and the core members of the contributing team, and there is definitely a desire to keep supporting the next version of OpenAPI. So one of the reason why the fork happened, the team wanted to support OpenAPI version 3 much earlier than the previous project. And if there is the next version, then obviously there is always a desire to keep supporting that next version, and also adding more and more technology stacks into the fold. So trying to be a really open project where people can contribute in a faster pace.
Yeah, that makes sense. Today, so we see a huge list of sponsors, not at least of users. Sorry, at least of users. Did you have any use case that you discovered that were not intended?
Well, the main thing that for me was really to use that OpenAPI generator for infrastructure as code, which was not what most people were thinking of using it for. most of the time APIs are tied up to web services, right? So REST API and all this thing. But I ended up using it for infrastructure stuff. So integrating, if an application needs to be configured by an array of other tools, dealing with provisioning users, groups, assets, permissions, and those things need to be integrated into other tools, which are really uncommon in the API space. In this case, the Puppet and Sibyl. And yeah, like I ended up using the SDK clients as well for really integrating infrastructure provisioning. So that was really unintended.
Yeah, I think that's quite straightforward. We reach our time, but yes, it's a great project. I invite you to use, join, or contribute or sponsor. Thank you very much, Cliffano, to be there with us. And again, we'd love to have you again in other OpenAPI technology tracks.